Hi, I'm Nadia. When you look at the night sky, you see plenty of stars. How can you see them? Of course, with your eyes. But did you know your eyes have limitations? What you perceive is just a small part of the entire picture. We are evolutionarily adapted to see the visible region of the electromagnetic spectrum. Haven't you wondered why we are adapted to only a small region of light? A star like Sun mainly emits electromagnetic radiation on that particular part of electromagnetic spectrum. So, what is radiation? Radiation is nothing but the emission of energy which travels and spreads through space. Just like if you light a candle or a torch in the dark, you can clearly see the propagation of light. Electromagnetic radiation is the electromagnetic field energy propagating through the space. Stars, galaxies, nebula, and all the visible matter in the universe emits energy in the form of electromagnetic radiation. This radiation includes radio waves, microwaves, infrared waves, visible light, ultraviolet rays, Xrays, and gamma rays. Electromagnetic spectrum is the continuous range of all these electromagnetic radiation. Let's look closer into different electromagnetic radiation. Radio waves, which is of course a familiar term. The best example is radio communication. Radio waves have a wavelength, that is the distance between two crusts or troughs, about 10,000 km to 1 mm, that is as big as the entire size of the earth to as small as the tip of a pencil. And frequency, which is the number of cycles per second, is between 30 cycles per second to 300 GHz. The mobile phone in your hands capture radio wave signals. Radio waves are the least energetic compared to all the other electromagnetic radiations, including visible light. Stars and galaxies in space emits radio waves. Next is microwaves. Microwave ovens are used in our kitchens. It uses microwave radiation energy to cook food. This type of radiation has wavelength ranging from 1 meter to 1 millimeter, and its frequency range is 300 million Hz to 300 GHz. It is used to learn the structure of galaxies. The entire universe is filled with the cosmic microwave background, or CMB, which is the remnant heat left over from Big Bang. Moving on to infrared radiation, just like radio and microwaves, infrared is also invisible to humans, but certainly we can feel it as heat. All objects in the universe emit some level of infrared radiation. Infrared light helps astronomers to map dust between stars. You can see the purple color in the picture is cooler than the bright yellow color. Night vision goggles pick up infrared light emitted by the objects, thus allowing us to see in the dark. It has wavelength just above the visible light and frequency about 300 GHz to 430 THz. Next is visible light, the narrow band of spectrum in which we perceive the world. It has a wavelength range smaller and frequency range higher than infrared. Next in the line is ultraviolet, which is also invisible to human eyes. It has a shorter wavelength and higher frequency than visible light. It is emitted from sun and other hot objects in space. UV rays are responsible to make tans and sunburns. As it has high frequency, it has enough energy to break down a chemical bond and can cause ionization, the process in which electrons break away from atoms. This can be beneficial for disinfecting the surface, but it can cause damage to our skin. Premature aging and skin cancer are the result of prolonged exposure of ultraviolet rays. Moving on to X-rays, when we have a fractured bone or a chest infection, doctors recommend to get an X-ray done. As X-rays are very high energetic radiation with wavelength range 10⁻⁻8 to 10⁻⁻12 meter and frequency 10⁻16 to 10⁻20 Hz, it has got a larger ionization energy. Its penetrating capability is much higher, which makes it possible to get a clear picture of our bond through which it won't penetrate. Astronomers study the X-ray emitted by hot gases in the universe using X-ray telescopes. Gamma rays are the most energetic of all the electromagnetic radiation, with a frequency of about 10 raised to 19 cycles per second and wavelength less than 100 petameter. Gamma rays are emitted as a result of radioactivity. Because of the fact that it is very much energetic, it has greatest ionization and penetrating power. Doctors use it to burn cancerous tumors inside human body. Gamma ray bursts or GRBs are the most brightest and the most energetic electromagnetic event known to occur in the universe, and it can outshine the entire galaxy. The most observed GRBs are thought to be released due to the violent supernovae, when very massive stars implode to become a neutron star or a black hole. From this picture, it is clear that the light we see is just a small region of entire electromagnetic spectrum. Then, how can we study about that invisible region? For that, we use different instruments which shows us light in different wavelengths. For example, X-ray telescopes like Chandra and E Rosetta allows us to see X-ray emission from objects in space. And if we want to study the universe in infrared region, we have to use infrared telescopes like Spitzer telescope. Thus, we use not only optical telescope, which we can see the world only in visible light, we also use radio and microwave telescopes, IR telescopes, UV telescopes, X-ray telescopes and gamma ray telescopes to learn more about the universe. Thus, we push our limitations to see, to comprehend the universe we live.